So, hi everybody, good morning. My name is Eitan. I'm the co-founder and CTO at Inigo. And the talk today is about observability, specifically for GraphQL, but overall observability in general. So, a little bit about me. I started my career as a networking software engineer, working at Sun Microsystems in Arista. And my love affair with GraphQL really started at Apstra. At Apstra, we were building a data center orchestration tool. So very similar to Kubernetes, what you have pods and this, but managing the whole data center. And we had a REST API, everything was fine. This was like 2015, very early GraphQL. One of my coworkers sent me this blog post from Facebook GraphQL. I looked at it and I was like, wow, this is perfect for us. We can, the whole network is really a graph model. We built this automated API. You can model the whole network. You can get all your servers, all of this, all throughout this GraphQL API. It was perfect, and I never looked back after that. So after Apstra, I worked at Observe. We did GraphQL from the get-go, observability platform for cloud, so similar to Splunk. And then after that, I founded Inigo. And our goal at Inigo is to build the best tools, tool chains, platform for GraphQL as a first-class citizen. Everything is GraphQL. We do a lot of stuff across GraphQL. We do schema management, breaking changes, dev tools, analytics, all kinds of stuff, rate limiting, security, all for GraphQL. So today I wanted to talk about observability. And observability is a big space, and there's really multiple aspects to it. There is like a peacetime observability. Everything is running great. You just want to know what's going on. And then there's like a wartime observability. You know, errors are happening, hosts are going down, and you really need to figure out what's going on now. So it's a very big spectrum. The thing to start thinking about when you think about observability is what kind of questions you want to answer. What kind of questions are you going to ask your tool? What kind of information are you going to get from your tool? And this also breaks down into many, many categories. I try to kind of think about some of these categories. So we have like infrastructure questions. Is my infrastructure healthy? Which hosts are overloaded? Which CPU, memory usage? What's going on in all my infrastructure? Are the services meeting their expectation? And if you have a subgraph compose schema, where are the actual requests going to? Which subgraph is getting hit? These kinds of questions. Your platform team, your infrastructure team is probably very, very interested in this kind of information. We also have performance questions. We want to know which resolvers in my server are slow. We want to know if there was a specific change, a specific commit that caused some degradation to the stuff. We want to be able to pinpoint that very quickly. We want to know if there's performance issues, if they're like scale related. Is it because my server is overloaded? Or is it because there's some problem in the code and I need to implement better? And for clients, and especially in GraphQL, okay, we might go through these hiccups here. Sorry, guys. I blame the dongle. Okay. So for GraphQL specifically, we want to know if the clients are fetching too much data. Are they fetching more data than they need? Stuff like that, performance related. We have usage questions, which are very, very important and very interesting. What part of my API is actually getting used? Which part is not getting used? Which part can I start deprecating? Is it safe to deprecate it? If it's something is deprecated, can I remove it? Is it safe for me to completely, is it time for me to completely remove this API? And Also, the product team could have questions like, I released this new feature. How is it getting used? Who is using it? Which users are using it? Which clients are using it? And if you have a access control set up on your schema and you have different roles and different accesses, it's very, very important for the observability to tell you actually who is accessing what, so you can kind of verify that a user that's not supposed to access something doesn't access it. Maybe you have your configuration wrong, maybe there's some problem. So it's very, very important to, at some point, verify that access is getting done correctly. Then we also have stability questions. Do we have errors in the API? Are users getting errors? What errors are critical and what errors are not critical? It's very, very hard when you see full picture, you have a lot of stuff running, and you have a lot of errors. It's very, very important to distinguish ones that could affect real usage and ones that are maybe lower severity. And when you do have errors, how do you debug these errors? How do you actually get to the clue of what's going wrong? Where is it in your system? So these are all observability questions. Then we have abuse questions. Are people abusing my API? Are certain resolvers getting hammered too much? Something overloading? Somebody is scraping my API. So I have like this API of some data, and I have these scrapers coming in, and they keep scraping my API. How do I know that these are the clients that are scraping my API? Maybe I have somebody trying to hack my API, so I want to find like suspicious activity in my API. These are all abuse questions. So in terms of observability, the kind of common pillars of observability are logs, metrics, and traces. This is the stuff you kind of hear about. This is the stuff you want to implement. And they each kind of serve a different purpose on this stack and answering these questions. So just going through them a little bit, metrics are basically gauges, time series. They're usually stored in the time series database. They're good for benchmarking, they're good for performance, they're good for kind of knowing what's going on in your infrastructure at real time and also after the fact. Logs are your most common thing, right? You can just print out here, print out there, print out everywhere. Usually people print out too much. You have to be careful. You have to set levels, debug info, this kind of stuff. It's very, very hard to track that you have too many prints too. But it's very, very easy to implement. It's a great tool for debugging. It's a great tool for troubleshooting stuff. And the kind of problem with logs is when you start having many, many services and you have many, many logs everywhere, it's very hard to correlate stuff. What happened? How did this happen? Where did it come from? These kinds of questions are hard to answer with logs, but logs are very good at kind of debugging a single service. So the most kind of recent addition to this observability stack that started showing up in the past decade or so are traces. And traces are like a perfect fit for GraphQL because you can essentially trace the whole request going through your whole infrastructure or through your GraphQL server. Every resolver in your server can become a little span in the trace, and you can see exactly everything that happens in your deployment, in your service. There's a great OTLP standard. It's very, like the trace part of it is very stabilized. There's collectors. Most of the servers today are instrumented already, so you get some stuff for free. But that's not the whole story with traces, because traces still require dev effort. You'll still need to add all kinds of code to add custom tracing, to add context to your traces. So it's a pretty significant dev effort to kind of bring this into your infrastructure. But most of all, traces are very, very expensive. So if you look at like a GraphQL request, let's say a medium-sized request, it has a lot of different resolvers. If every one of these is a separate span, each one of these spans ends up being an event, ends up being a row in the database, and this can get very, very expensive very fast. It can become orders of magnitude more expensive than your logs and other stuff. And the solution that we use at Inigo and what we really like is basically selective tracing. If you have a high-scale API, lots of requests, collecting everything all the time doesn't always make sense. You want to be able to figure out where the problem is, which API request, and you can do that with other tools. And then you can enable this selective trace to kind of diagnose the problem to the very end. So these are the kind of pillars of observability. But my argument is that for GraphQL, we need more. And what we need, I call it path-based analytics. Essentially, what you want to do is you want to take every GraphQL operation that comes in, you want to break it up into different paths of the query, and record some analysis for every one of these paths. And using this information, you can actually open up whole new doors for your observability for GraphQL. So we can analyze these paths. We can associate errors that comes with paths. We can associate them together so we can know where the errors are. And then at the end of the day, we can do group bys and filters and do all kinds of stuff and break this data down per user, per client, all kinds of stuff. This method is very low cost because you just have one row per every API request, which inside it has all the data for this API request, very compressed. And the other nice thing about this is whether you implement it yourself or have some other tools do it for you, it doesn't intrude into your code. You can do it completely at the GraphQL layer. You can have a library that kind of takes care of this, and you don't need to like start adding logs and traces into your code. It's completely separate, keeps the code base very, very nice and clean. So what does this look like? Let's say we have an example query here, very small. We're getting the user name, email, friends, name. When we analyze this query, we're going to break it down into all the different paths that are inside this query. So we're going to have a line essentially per field that we're asking in the query. And for each one of these paths, we can record different types of information. So one thing we can record is how many times this thing was asked for. That's, I kind of compressed it into this list, but the value on the left is how many times this thing was asked for. The value in the middle is how many objects got returned for this path, so we know which paths are kind of getting a lot of data, which paths are making less data. And if we instrument the server right, we can even record how much time each path takes. And we can almost get a trace. It's almost like a data of a trace, but it's much more compressed and much more efficient. So what kind of stuff can we see with this data? These are a couple of views from our product. This is, I hope it's big enough. We call this a tree view. It's essentially a superset of a lot of queries that you can filter. So you can say, filter me this user and give me a superset of all the queries that he has made in the past whatever amount of time together. And you can go through and you can see exactly what this user has been doing, which paths he's accessed, and etc. Another very nice view that we get from this type of data is a schema coverage view. You can, again, filter by whatever you want, whatever time, whatever client, and you can see exactly which fields in the schema are getting used, which are not getting used, how much are they getting used, all this kind of stuff. So this is the kind of information we can get from a path-based analytics. So going back to our questions, in the infrastructure world, most of your answers are going to come from metrics. You're going to have host metrics, you're going to have device metrics, you can have API metrics on calls and stuff, and most of this data is great, suitable for metrics. Which subgraphs, you're now getting more into like paths and stuff, so the path-based analytics really works well here. Performance answers. So which resolves are slow? The best tool for this is actually Trace, but again, Trace has its drawbacks, and you can almost get the same stuff from this path-based analytics. If you're looking for changes and looking for timing, looking for stuff, metrics are good. And if you're looking for clients and trying to see what clients are overfetching data, underfetching data, again, this little piece of data gives you exactly what you need for this. Usage answers. This is where path-based analytics really shines. You want to know who is accessing what. You want to know which features are getting used. You want to know all this stuff. And with GraphQL, because everything is inside this query, you really, really have to parse the query, analyze the query, in order to get this information. You can't just get it from looking at the HTTP request or anything else. You have to go inside, do this little bit of analysis, and then you can answer all these questions very, very easily. Even for stability, because we're talking about specific resolvers, trying to see what resolvers are getting hit and this kind of stuff, the path-based analytics works really, really well. Essentially, in your whole GraphQL server, anytime you want to know something specific about something that happens inside this request, you're going to have to do some form of this path-based stuff, or trace the whole world and go and try and find the information in all your traces, which is also a challenge. So again, for abuse, our path-based works really well because we know which resolvers are getting hammered, who is scraping the API is very, very easy to see once you can filter by a user and see exactly what he's doing in the API. So all these questions are very nicely answered by these path-based analytics. The other big challenge with GraphQL is errors. Errors are hard because mainly for two reasons. One, it's very, very tricky to distinguish between a user error, an actionable error, and something that's a problem in the service. The actual error object is like ambiguous. The server can return you whatever error he wants, and as a client and as analytics on top, you really want to be able to distinguish between these because invalid token or invalid password is not the same as database not reachable. These are two very, very different things. The other thing is, even if let's say you can distinguish between these user errors and service errors, you could still have a lot of errors in your API, and it's very, very hard to distinguish which errors are critical and which errors are less critical. So being able to categorize these errors into some form is very, very important for observability when you want to see the errors that are really affecting your API. So just some examples and approaches that you could take. So let's say we have a very simple kind of create user API. It takes an email, a password, it returns a user, everything is good, and now somebody calls this API. So what kind of stuff can happen? There could be an invalid email, there could be an invalid password. There could be maybe this user already exists in the system, you cannot create this user. But then you can also have other errors, like there's a bug in the code and it throws an exception, or there's some database error or some infrastructure error. So you really want to be able to distinguish these user errors, which are user actionable and not a problem for you, okay? If the user already exists, you need to find a different name. That's not your issue. But the service issues, you really want to isolate those. And there's a few approaches to doing this. There's what I call the simple approach. The simple approach is you use the extensions field inside the error, and you kind of provide more context about this error. So the server can say, this is an actionable user error, or this is a service error. Your analytics can pick this up and can easily separate them. Very simple, but this is not the GraphQL approach. If you ask Lee Byron, he will tell you that the errors field in the GraphQL response is really for exceptions. Everything else you want to handle inside your GraphQL API. So what does this mean? What it means is that you create a type system for your user errors. So you create now if we look at this API now, our create user is no longer returning just a user, it's returning a user result. And a user result can be either a user in the case of a valid successful request, or it could return an invalid password, an invalid email. The other nice thing about this is that it forces your client to handle these things, kind of. It's not really enforcing, but the client can switch on these different stuff and actually handle them, and it's in the type system, so it's all introspectable. The client can know which errors are coming from what API. So this is a nice approach, but this approach also has issues. it could be that the create user can return multiple errors. And in this particular case, the way we have it here, we can actually only return one error to the API. So if you take this a little bit further, you can create a very similar. You return, again, a user result, but inside you return a list of errors. And this list of errors is a very good use case for a GraphQL interface. And if you see, we're kind of reinventing the errors in the actual request, but now we have them typed, and we have all our different user actionable errors typed. So we know that if we get an error in the API, it's an exception. Otherwise, we get these types, and the client can do whatever it needs to handle them. The other problem, or the other challenge with errors is how, okay, so now I have distinguished my actionable user errors, which are okay and not an issue, with my service errors. How do I now take all my service errors and actually categorize them so that when I go and look, I can filter them out very quickly and know which are issues, real issues. So for this example, we have like our API, we have a send payment API. This is a very important API for us. We want to make sure that the send payment always works. And if there's an issue with send payment, we want to know right away. We want to be able to isolate it. Create user is important, but maybe not as important. And then we have some other APIs that are less important. So the approach that we have for this is an ability to tag each field in your schema and give it whatever label you want. And then going back to our path-based analytics, because we know the requests, because we know the path in the error, we can correlate all this together with our tag level for this API, and we can actually like group by and separate all these errors, and you can see your level 0 errors, your level 1 errors separately, and it makes it very convenient for kind of running a big system that you always want to keep running, and you don't want to look at millions of errors. So that's about it. That's my summary. Metrics for infrastructure, logs for debugging, tracing. If you have a large-scale API, use it selectively. And path-based analytics are really help kind of put everything together, the whole picture together. And that's it. Thank you. I want to thank the guys that run this conference. It's really amazing. It's amazing to see such a GraphQL community come together. Yeah, and I hope we grow. And thank you. Any questions?
Talk a little bit about alerting. You said you've got these analytics and observability.
Yes. Yeah. Totally great question. So the question is about alerting and how do you create alerts from your analytics. Alerting is kind of I would say a layer on top of these analytics. And what you can do is essentially what we have done is any filter that you can do in the API. So you can filter by users, by clients, by specific paths, by all these kinds of, you have a lot of control. Does it have an error? Does it not have an error? You can create an alert from this filter. So you can create a filter and give it like a time window. You say, if this thing, 10 events or 20 events happened in 5 minutes, in 1 hour, send me an alert. And then the alert essentially generates an event. That event can be exported to whatever system you want, Slack, Datadog, whatever, Splunk. And the other nice thing is that from this alert, you can actually get the filter and go back to your analytics and see exactly what caused it. So, great question. Any other questions? Come visit us. We have a booth if you want to learn more. And have a good day.